In our last section, we began talking about equivalent statements. And just to remind you, two statements are logically equivalent if when we form the truth table, their values are identical for each set of inputs. And so that is always true in general. And then what we talked also last time was a specific equivalence of the conditional statement with its contrapositive. And so what we're going to do is just continue a little further with a couple other of famous and popular equivalences that you can always demonstrate are true, but you can also just remember these and take them to the bank. So the first one is what happens when we negate or form the negation of a conditional statement. So I've written that out symbolically. We got a conditional statement right here, if P then Q. I've put a squiggly in front of it to indicate the negation. And so what we know to be true, and you're going to show me this in a second, is that when you negate a conditional statement, that is equivalent. Remember, the equal sign with the 3 bars means logically equivalent to P and squiggly Q. So what that means is you take the condition and you leave the condition alone, okay? You never touch that. And then when you're negating, whatever the consequence is, you make it the opposite and you join them together with an and. So here's what I would like you to do, please, just to practice and make sure we're staying up to date with our truth tables. Exercise 1 is for you to do. I want you to demonstrate that this equivalence is true. Meaning, I want you to form a truth table for this statement right here, squiggly, and then parentheses, if P then Q, and then form a truth table for this statement here, P and squiggly Q, and show that they are the same. Please push pause, go ahead and do that, and then when you're done, push play and check what you did with what I did. Okay, so here goes. You're pushing play. Hopefully you took seriously the opportunity to do this. Remember, learning happens when you do things on your own. Even if you make mistakes, that means you're learning. And so here we go. I'm going to fill in my 4 basic truth table values. Okay, these are always the same. And now I'm going to do do what's on the left. So first, I'm going to do if P, then Q. That's my conditional statement. Remember, the basic truth table fact for the conditional statement is that it is always true, except when you have if true, then false, meaning the condition is true, and then the consequence was false. It did not happen. So what we have is P, then Q, true, true, then false. That's the false one. False, then true. That's true. False, then false. That's true. And now what I'm going to do is I'm going to negate that. So that's what it means to have parentheses and a squiggly on the outside. And so the negation just changes the value. So this column right here, that is TFTT, I am going to flip and make that FTFF. And there we go. And I'm going to put a little asterisk under that because that is the first of our 2 columns. And now what I'm going to do is truth table for what's on the right. And so on the right, I need first a squiggly Q column. I got to negate that Q. So squiggly Q, Q is TFTF. So squiggly Q is FTFT. Now I'm going to join that together with an and with P. So I'm going to put a little dot just so that I know which columns I'm using. So I've got P and squiggly Q. That's the conjunction. And remember, the conjunction is true when both statements are true. That's the only time. So when I go ahead and do P and squiggly Q, I've got true and false. That's false. I've got true and true. That's true. False and false. That's false. And then false and true. That's false. And so that's my second. And so notice this column right here for what's on the left up above and this column here for what's on the right are exactly. And so that means, yes, they are equivalent. So that is you demonstrating that equivalence. You're going to get to do that again on the next, on the second page when we talk about the other equivalence for the day. But in the meantime, what we're just going to do is practice this equivalence so that we remember it. So here's my example to help practice. What we're going to do is we're going to write the negation of this statement here. If the door is unlocked, then I am home. So always when we are working with statements and words, we are going to define our 2 simple statements. So I'm going to define the statement P to be the door is unlocked. And then the statement Q is going to be I am home. So what that means now is when I take this statement right here and I translate it into symbols, if the door is unlocked, that is P, and then I am home, then Q. So now the negation of that, when I negate, okay, so the negation of that, when I negate that, and I use this right here, remember when we negate it, we take the condition, we leave the condition alone, we take the consequence and we negate it and join it with an and. So we take the condition, we leave it alone, we use an and, we take the consequence and we make it the negative. So the negation of if the door is unlocked, then I am home is the following statement. The door is unlocked. And I am not home. That's what squiggly Q is. The door is unlocked is P. I am not home is, squiggly Q is I am not home. All right, so easy enough. It's just a matter of translating and then using that property of the negation of the conditional. So I would like you to do the same thing for the exercise that's right below. And again, you're watching the video, so if you would push pause and then go ahead and do the exercise, we can check work together in just a moment. Okay, so I'm assuming that you took time to push pause and now we are checking your work together. And so here goes. Then we're going to write the negation of if you have a fever, then you have the flu. So I'm going to let statement P be you have a fever. And statement Q is you have the flu. Excuse me. So taking this conditional statement and translating it, if you have a fever, that is statement P, then you have the flu, that is statement Q. So this is pretty much identical to what we did right above, which is good. Now you did it, so hopefully you remember it better. And so the negation of that, when I negate this conditional statement, it looks like this. You take the condition, you leave it alone, and you take the consequence and you negate it. That is the negation. And now I'm just going to write that in words. So statement P right here is you have a fever. And squiggly Q is you do not have the flu. Perfect. All right, so try the next one. Remember, little hint, whenever you define your simple statements, you define your simple statements positively, and you add in the negation when you write it symbolically. So give exercise 3 a try, please. Push pause, work it yourself, and then we will compare notes. All right, so I'm hoping you pushed play again. So here we go. I'm going to let statement P, since we have if you are not home, then you're at school. Statement P is you are home. Remember, we always define our simple statements in the positive. We add the negation in later. Q is you are at school. So when we write this conditional statement symbolically, if you are not at home, that is squiggly P, then you are at school, that is Q. Now we're going to negate that. Well, again, what's the rule? The negation of a conditional statement is I leave the condition alone, and whatever the consequence, I negate that, and I connect it with an and. Okay, here goes. I leave the condition alone, squiggly P, and I take the consequence, and I negate it, so squiggly Q. And now we'll write that in words. So, squiggly P, you are not at home. and you are not at squiggly Q, you are not at school. All right, one more, just to make sure you've got the hang of this and you're feeling great about it going into your homework. Exercise 4, do the same thing, push pause, work it, and then push play, and let's see how you did. Okay, here goes. So what we're going to do is we're going to define P from my statement. If you are not in Florida, then you are not in Miami. So if you are not in Florida, we define our simple statements in the positive. So you are in Florida. Then statement Q, since this says you are not in Miami, we define it positive. You are in Miami. So my statement, when I translate it into symbols, is if you are not in Florida, that is squiggly P, then you are not in Miami, squiggly Q. So one more time, we're going to form the negation. And the negation looks like this. We take the condition, we leave it alone. So squiggly P, we leave it alone. And we take the consequence and we negate it. So it's already squiggly Q. So when I negate that, it becomes just plain old Q. And now I'll write it in words. Squiggly P, you are not in Florida. And Q, you are in Miami. Perfect. All right, we're going to flip the page. We're going to look at one more equivalence. So that is the negation of a conditional statement and what it is equivalent to. So here we go. We're going to flip it over. This last one is one of the more famous ones, one of the original developers of the field of mathematical logic. Was a man whose last name was DeMorgan. And so this is an equivalence attributed to him. It's called DeMorgan's laws. DeMorgan's laws can be thought of as almost like a distributive property. It's not exactly a distributive property, but we can think of it like that. Well, what to do with the negation when I have parentheses and I have either an and or an or inside the parentheses. So the pattern is the same, whether it's an and statement or whether it's an or statement. What we can do, we can notice we cannot do this when we have a conditional statement. We saw that on the previous page. This only applies for ands and ors. But what we can do now is I can take that negation, that squiggly, and I can distribute it. So I can take squiggly P. But then what you need to do for DeMorgan's law is you don't leave this an and, you flip it. So it becomes an or, and then I distribute squiggly Q. So I distributed the squiggly to both the P and the Q, and I had to flip the sign. Same thing's going to be true if you start with an or. I'm going to distribute the squiggly to the P and the Q, but this time instead of it being an or, it's going to change to an and those are equivalences. So the first thing that I'd like you to do for me right here is in exercise 5. I want you to push pause on the video, and I want you to just show the first one of the DeMorgan's laws is true, that when you have a squiggly outside of a P or Q, that it is equivalent to squiggly P and squiggly Q. Do that using a truth table. Okay, I hope that you did that. So you've pushed play. So first thing I'm going to do is I'm going to fill in the truth table with my 4 combinations of trues and falses. And so first thing I'm going to do is this one on the left, the squiggly outside. So I need a P or Q column first. The disjunction is true when either one is true. So here we go. True or true is true. True or false is true. False or true is true. False or false is false. And now what we're going to do is we're going to negate that. We're going to put a squiggly right out in front of the whole thing. And so now when I flip the switch at each of these, true becomes false, and then false becomes true. So this is the first of the statements. I'm going to put a little asterisk right there so we can compare. And then the same thing for the next one. So first I'm going to do a squiggly P column. Squiggly P is false, false, true, true. Squiggly Q is false, true, false, true. And now when I join those together with an and, we remember that the conjunction is true only when both are true. So false and false is false. False and true is false. True and false is false. And then true and true is true. And again, we have demonstrated DeMorgan's law. This column FFFT and this column FFFT are exactly the same. So we can say yes, they are equivalent. Okay, so how we're going to end our time in this section is doing something similar to what we were just doing with the negation of the conditional. We are going to use DeMorgan's law to write an equivalent statement for each of these things. So here's my example. Then we have a few others we're going to go through. So this says it is not true that Atlanta and California are cities. So first, my simple statements. Statement P, statement Q. Statement P is that Atlanta is a city. And statement Q is California is a city. Okay. If you remember from a few sections ago, when we have it is not true means that what you're going to do is you're going to put a squiggly and then parentheses. So it is not true that Atlanta and California, so P and Q are cities. DeMorgan's law, what DeMorgan's law says is that I can go ahead and I can distribute that. Okay, so I can distribute that negation as long as I flip the sign. So this becomes squiggly P or squiggly Q. Those two things are exactly equivalent. And now I will write that in words. And so I've got squiggly P. So Atlanta is not a city. Or California is not a city. And there you go. That's the process. So I'd like you to do that with exercise 6. Please use DeMorgan's law for the statement, it is not true that Taylor Swift and LeBron James play in the NBA. Push pause, go ahead and do the problem, and then we'll compare notes. All right, your push and play. Here we go. So first, I've got to define my two simple statements. So simple statement P is going to be Taylor Swift plays in the NBA. I'm just going to abbreviate Taylor Swift, TS, plays in the NBA. And then LeBron James, LJ. So this statement right here, it is not true. So I put a squiggly and then parentheses. Taylor Swift and, so that is P and Q. So this is essentially the same problem that I just did. But again, it helps you learn for you to go through and write it down and sort through it on your own. So this is going to be equivalent to when I distribute with DeMorgan's law, squiggly P or squiggly Q. So let's write that in words. Squiggly P is Taylor Swift. Does not play in the NBA. Or squiggly Q, LeBron James does not play. And there we go. Those two things saying it is not true that Taylor Swift and it's not true that both of them play in the NBA, which we know that is a true statement. They both do not play in the NBA. And so this is equivalent. Taylor Swift does not play or LeBron James does not play. One of those two things is true. I've got one more example, and then you've got two more, and then that'll be the end of this little section on Morgan's law and the negation of the conditional statement. So we're going to use DeMorgan's law to write an equivalent statement to you do not leave by 5 p.m. or you arrive home on time. Okay. So again, we define our simple statements positively. So statement P is you leave by 5. And statement Q is you arrive home on time. So that means the statement that I have, you do not leave by 5 p.m. So that is squiggly P. Or, so there's my or symbol. You arrive home on time is Q. Now, this time, we're not distributing. We're going to do the reverse. Okay, so I know that algebra for some people is very painful, but we're going to think back to our algebra experience. And what we're going to do is we're going to undistribute the squiggly. So I'm going to put a squiggly out front in some parentheses, and we're just going to use DeMorgan's law in reverse. So if I have squiggly P, when I take out the squiggly, I'm just left with P. Using DeMorgan's law in reverse, if this is an or, that means that it must have been an and first. And then if I have a Q and I take out the negation, that means I have a squiggly Q. Two negatives make a positive. And you can now look at it in the more familiar way. I've got squiggly P there, change the and to the or, and then a squiggly Q just leaves me plain old Q. That's why you're going to do two examples, is so you get used to that process, because I know that's probably a little bit awkward at first. Now we're going to write this as a statement. And when we have a squiggly out in front of parentheses, we start off with it is not true, or it is false that, whatever. It is not true that you leave by 5 p.m. And squiggly Q, you do not arrive home on time. Sorry, I went off the screen a little bit right there, but there you go. You get the gist of it. All right, push pause. Exercise 7. It's going to be super similar. I want you to go ahead and use DeMorgan's law to write an equivalent statement to that. The dog was not a bulldog and the dog was not a boxer. All right, so pushing play, here we go. Statement P is the dog was a bulldog. Statement Q is the dog was a boxer. So the statement that we are given, the dog was not a bulldog, is squiggly P. And the dog was not a boxer, that is squiggly Q. Again, we're going to use DeMorgan's law, and we are going to undistribute the squiggly out of that. So I'm going to take the squiggly out. I'm going to put some parentheses. And so when I take the squiggly out of the squiggly P, that just leaves me P. DeMorgan's law says you have to reverse the sign. So instead of and, it's going to be or. And then when I take the squiggly out of squiggly Q, it becomes just Q. That's the hard part. Writing it in words is probably not the most stressful part of this problem. So the squiggly is out in front of the parentheses. So I say it is not true that, or it is false that. P, the dog was a bulldog. Or the dog was a boxer. All right, one more problem. So go ahead and push pause, do this one more time, using DeMorgan's law to write an equivalent statement to the sun is not shining, but remember, but is another form of the conjunction. It is raining. All right, here we go. Let's finish this up. Let me get the light to turn back on in this room that I'm in. Keeps going off on me. All right, here we go. Statement P is the sun is shining. Always define those simple statements in the positive. Be positive. Statement Q is it is raining. So here we go. The sun is not shining is squiggly P. But is a form of the conjunction. So and it is raining Q. DeMorgan's law. Let's take that squiggly out. We're going to undistribute it. So when I take the squiggly out of squiggly P, I'm left with P. DeMorgan's law says always reverse the sign, so it becomes an or. And when I take the squiggly out of plain old Q, that means I have squiggly Q. Squiggly, squiggly. Two negatives make a positive. And now I'm going to write this in words. So I'm going to say it is not true that P, the sun is shining. Or squiggly Q, it is not raining. And there you go. There are your DeMorgan's law in addition to your negating of a conditional statement. Good luck.